You might have heard the word microcontroller before, but did not put much significance to the term. But did you know that microcontrollers are present in many of our modern day appliances? Take, for example, a microwave oven. The microcontroller in this device takes input from the keypad, displays this information in an LCD screen, and turns the oven on and off. Vending machines have microcontrollers too. They detect coins drop into the slot, discharge the drinks, and remotely keep track of the number of items inside. A modern day automobile even has 20 to 50 microcontrollers that can communicate with one another. A car's microcontrollers get real time data from many sensors, analyze them, then perform actions such as displaying the car fuel's level, deploying emergency brakes or the airbag, and many more. Microcontrollers are truly powerful machines. They are actually referred to as little computers in a chip. Of course, they look less complex than the personal computers that we know of, but that's because our personal computers are general purpose computers. This means that they are meant to perform a wide variety of actions, such as word processing, editing videos, printing documents, accessing the web, and many more. However, microcontrollers are made to perform a specific task based on the program uploaded into it. Still, they are computers in a sense that all primary parts of a regular computer are present in them, such as the processor, the memory, and the input output peripherals. To make sense of these parts, let's compare microcontrollers and computers with our human body. Bodily functions are controlled by the brain, our own personal processor. The brain stores information as memories, which allowed it to perform actions more efficiently in the future. We gather data from our environment through our senses. Our brain, in turn, can command other body parts, such as our hands, to react to these stimuli if necessary. Just like the human body, the microcontroller works best if it is in tandem with sensors and actuators. Sensors, just like our senses, are able to read data such as temperature, humidity, sound from the environment. Meanwhile, actuators are devices that produces outputs based on this data. In an air conditioner, a simple sensor can detect pressure applied by the user on the keyboard while turning the AC on or managing its setting. But more sophisticated sensors, such as those that measure the room temperature, are also present. Based on this data, actuators display the temperature reading on a screen or activate the swinging blade system to distribute the cool air throughout the room. Sensors, which are also called input devices, and actuators or output devices, are attached to the Arduino UNO microcontroller through the input output peripherals. Now that you know what microprocessors are, you are ready to take a closer look to the Arduino board. The Arduino is very popular with those just starting out with electronics because it simplified the process of uploading codes into the board. Instead of using an additional hardware called the programmer to do so, Arduino just requires you to use a USB cable to connect it to a computer. Additionally, Arduino uses a simplified C and C++ as its language to make the coding easier to learn. For this video, we are going to look at the parts of Arduino Uno R3. This board can be powered using the USB cable coming from a computer. The USB cable then serves as the bridge between the board and the computer where the programs are written and uploaded from. The board can also be powered through the power or the barrel jack where the batteries can be connected. The recommended power supply for this board is between 6 to 12 volts. Excess voltage will be dissipated as heat as it can seriously damage the board. To manage excess voltage, Arduino UNO has a voltage regulator. The microprocessor is considered as the brain of the board. This is the black rectangular box with many legs, 28 in total, and is also called the main IC or the main integrated circuit, the CPU or the computer processing unit, or simply the microcontroller. It is responsible for reading and executing the programs uploaded into the board. When uploading a program into the board, the TX RX LEDs light up. TX stands for transmit and RX stands for receive. Another built-in LED is present near the Arduino UNO logo and marked as on, which is the power LED indicator. If you plug in the Arduino and this LED did not light up, it means that there is something wrong with the circuit. Sometimes it's also helpful to reset your program, which you can do by pressing the red button near the USB port called the reset button. To attach other components such as LEDs, buzzers, LCD screens to the Arduino, you use the header pins in conjunction with the breadboard and the wires. There are three groups of header pins: the power pins, analog pins, and the digital pins. Power pins are, of course, useful in providing power to your circuit. UNO can supply 5 volts or 3.3 volts of power. 3G and D or ground pins are also present, which provide 0 volts of power. Diodes such as LEDs have two legs, one positive and the other negative. The positive or the longer legs of an LED must be connected to any of the pins in which 5 volts or 3.3 volts of power can be supplied, and the other shorter leg to the GND to create a close connection. The group of pins under the label analog in are analog pins, A0 through A5 in UNO, devices that can read or take in analog data such as temperature or variable resistance can be plugged in here. Unlike digital data, which are binary, an example of which is high or low of an LED, an analog data is continuous. A room temperature reading is continuous in a sense that it's not simply cold or hot, but specifically 27 degrees Celsius, for example. Meanwhile, pins that are labeled digital, 0 through 13 in UNO, are useful for both reading digital input, such as if a button is pressed, and executing digital output, such as flashing an LED on or off. Some of the digital pins have a tilde sign or the squiggly line present after the pins 3, 5, 6, 9, 10, and 11 on the UNO are capable of PWM or pulse width modulation. To explain it simply, these digital pins can also simulate analog output. For example, the LED attached in these pins can be made to fade in or out, controlling its brightness level rather than it simply turning on and off. And those are the main parts of the Arduino Uno. Take note that other variations of the board may have other parts or even look completely different due to their functionalities. Take for example, the LilyPad Arduino, which can be sewn to fabric and can be connected to power supplies using conductive thread. It's perfect for wearable projects. Meanwhile, the Arduino Mega has more digital output and input pins, 54 in total, for projects that require a large number of connections. However, the Arduino Uno is a good place to start. It being the first board to be developed, it has all the basic functionalities you need as a beginner in electronics.